This demonstration covers my brief lecture on the Rutherford experiment. The demonstration explores an aspect of the experiment itself. I have a depiction here of the experiment on the board, and I lecture about this experiment in class. Once again, the experiment is conducted in the following way. Rutherford began with a chunk of uranium. Uranium is naturally radioactive. As it undergoes a process called radioactive decay, uranium nuclei are decaying into lighter elements. Radioactivity was not understood at the time, but Rutherford knew that he could use the process of radioactivity for exploring the inner constituents of matter. As uranium undergoes radioactive decay, it emits what are referred to as alpha particles. They were just simply called alpha particles at the time in 1911 by Rutherford and his colleagues. Since then, however, we know exactly what those particles are made of. They are actually helium-4 nuclei, and they are positively charged. As they are emitted from uranium, as uranium undergoes radioactive decay, those alpha particles are actually moving at a pretty good clip. So then therefore they have a high amount of energy. And then basically what Rutherford did was he directed those alpha particles into a thin gold foil target. He used gold because gold is very malleable, it's soft. This means that it can be shaped. So the thin gold foil that he shaped the gold into was basically only a few hundred atoms thick. So he used a nice analogy to describe the situation. It's like trying to, for example, take a rifle and fire then high velocity bullets at a thin target of tissue paper. And then of course, for the most part, you would expect all of those bullets to go directly through the tissue paper. And for the most part, that's exactly what happened with these helium-4 nuclei, with these alpha particles. They went through the gold foil as if nothing was there. He could detect these particles, by the way, by placing a screen here on this side of the experiment that was coated with a specific chemical compound called zinc sulfide. Zinc sulfide fluoresces, in other words, it gives off light when it's struck by charged particles. Now, for the most part, this is exactly what happened more than 99% of the time, but less than 1% of the time, one of the alpha particles, positively charged, would appear to hit something deep within the gold atoms themselves and then get kicked off to the side. By looking at the details of the collision, Rutherford was able to mathematically work out basically the existence of the atomic nucleus, in this case the atomic nucleus of gold. Now, how did he know, for example, that a deflection or a collision was happening here, deep within the gold foil? Well, he placed additional screens, for example, off to the side at various positions in the experiment. So here's the demonstration that I want to briefly show in this video. I want to show you an example of just simply one of these screens. In other words, one of these screens that fluoresces when it is struck by charged particles. So I'm going to do that here with this setup. What I have right here is a transformer. A transformer creates a really high voltage. Think of voltage as basically a really steep hill. And then right here, this device is what is referred to as a cathode ray tube. This cathode ray tube is very simple. It just simply consists of two metal spikes that are pointing at each other like so. And then right in between here, I have a screen that is coated with the chemical compound of zinc sulfide. The voltage that is created between these two metal spikes, the steepness of this hill, is so large that it's able to literally tear electrons out of one of the metal spikes, and then those electrons basically fall downhill towards the other metal spike. And as they do, those electrons then strike this screen. When the electrons strike the screen then fluoresces, it gives off light. So of course you can't see the individual electrons themselves, but you can see their effects. So let me go ahead and turn this on like so. And then you can see that the green light that's being emitted here on the screen, that's the result of the electrons then striking the zinc sulfide and thereby causing the screen to fluoresce. Let me go ahead and turn off the lights so you can see this a little bit more distinctly. Like so. And so Rutherford was ultimately able then to use these zinc sulfide screens kind of scattered around his experiment to detect the collisions that were happening within the gold foil. Okay, that concludes this video.